Hey, I'm Bob Abrahamson from Waltron, and welcome to this week's edition of View from the Road. Waltron serves clients across the country, and we have a phalanx of sales representatives, service technicians, and with us today is our senior application expert, Greg Macy. And we're going to be talking to these folks to get some insights about what they're hearing in the marketplace when they're meeting with their clients on a daily basis. So today, again, Greg Macy, senior application expert. How you doing, Greg?
Good. Yeah, thanks for having me. I'm excited to share some of our experiences that we've had out in the field and to give some pointers to our clients that will help them in their online instrumentation and in the application. I think one of the first things I'd like to share is just a little bit about background. I started as a service technician with Waltron back in 99. I have industry experience for at least 25 years. And one of the things that we've seen in the industry, everybody that's listening to this can agree that the industry has certainly changed. And then when we're talking the power industry specifically, the nature of the beast has really evolved over the last 25 years, especially from when I started. And I wanted to really talk specifically about dissolved oxygen in boiler chemistry. In the application of dissolved oxygen, we've definitely seen a change, not only in the need for the application, but we've also seen the technology for monitoring the actual dissolved oxygen analyzers has really evolved. And I want to start off just by talking a little bit about the industry and how it's changed. And everybody knows that the industry has shifted into more of a cycling. So power plants are cycling the combined cycles, especially, but even the coal plants, we're seeing the nature of the beast. Run times are changing. They're starting up, they're shutting down. And that poses a lot of
that? What is the change specifically? Dig into that a little bit.
Yeah, sure. Power plants typically were base loaded. And especially when we talked about a coal plant, it would come online and they really wouldn't shut down unless they had an outage for maintenance. And so they would run for months and months and then shut down for a seasonal outage. And that has changed a lot in the industry. With the addition of a lot of natural gas combined cycle plants, they have also changed how they run. They used to come up online and they would normally run, again, pretty base loaded. Now they actually, because of all the different clean energy sources, they start these units up. And then when demand for the more electricity is on the grid, they would shut them back down. So these power plants are cycling the units up and down. And when we're talking about dissolved oxygen specifically, the older technology in the probes was amperometric or galvanic sensors. And what that basically means is that's just a fancy word for a battery. And so these oxygen sensors were just a battery that they would produce more current when they saw more oxygen. And so basically the more oxygen they're exposed to, the faster the battery dies. And so that technology really worked well for long periods of time. And then they were exposed to it here and there. Now these sensors are being exposed to it nightly. And when we're talking exposed to it, we're talking going from maybe 5 parts per billion all the way up to 8 ppm, part per million. And so they're being fully saturated in oxygen. And these sensors really
is that a function of them starting and stopping more often? What's making that happen?
Yeah, when the units are cycling or starting up, they're normally breaking vacuum and they're pulling in air. And then also the sample panels themselves either drain out or they're not to have low level. Sometimes they can actually isolate them and they can keep water and sample in there, but they're still going to be exposed to a lot of oxygen. And so essentially that's just going to kill these little batteries. So that old technology worked well back in the day when plants were online all the time. And now that they're cycling, these batteries basically are going bad within 3 to 4 months. And the problem with that is it's not as simple as you changing the batteries in your calculator, right? You have, when you remembrane and re-electrolyte a probe, it takes a technician. It takes time to get gloves on it. It's potassium hydroxide. It's the chemical typically that they use in these sensors. And it's just a maintenance kind of nightmare. And again, if you only had to do that once a year, which is what it used to be, and you now have to do it maybe once every month or two, then what happens is people just don't change. And so what I'm seeing in the field is when I go out there, I'm seeing, number one, the oxygen sensors, when they typically go bad, they fail on the low side, meaning that when the problem with the probe, they like to read low, like 0 or even in a power plant application, that's what they want to read. And so a lot of times these sensors are giving them false information The plant doesn't even know. It could be a problem. So if you have a condenser 2 leak or you have oxygen in your system, you might not even know. And I will go into a lot of plants that have this type of technology. I'll pull the sensor out and it'll read 1 or 2 ppb, right? That's a problem. It should be reading 8,500 in full air saturation. Okay, so it's a quick gallon dirty chair. If you're on this call and you want to test your sensors real fast, we'll go out there, pull it out, and dangle it in the air, and let it see full air. It should be at sea level around 8,500. Now, it could be 8,700 because you're at a different altitude.
If you're running so just to reiterate, because you gave a little tip there, which is great. So if you're running this technology, how often should these folks be doing what you're suggesting, going out and making sure the readings are accurate? Should be doing it bi-weekly, twice a month?
And they typically, almost every manufacturer recommend they have a monthly calibration. Okay. When you're doing calibration, you're doing there's 2 types of dissolved oxygen calibration. There's a zero where you're actually taking 0 water, which Waltron sells. We're one of the manufacturers in the industry that sells this water, which is chemically made, and it's got a beautiful cap that just you turn it and the solution drops in there. So it's ready to go right away. There's no mixing, there's no gloves. And I can just take any sensor, pop it right in there, and it should read 0. So that's a good 0 test. We have the 0 water for that application. But then when you hang it out in full air, you also calibrate it to full air saturation. Okay, so you're doing a 0 and then you're also calibrating. A lot of times manufacturers just say, just do the high level, the low level is fine because normally they're in that application. So where I'm going with this is this technology is just archaic, right? It was meant for an application. And then over the years, there's been newer technologies, patent one by Waltron here, luminescent technologies that don't require any kind of membrane. They don't require anything. It's light. Okay. So it's using light to excite oxygen molecules and actually be able to monitor. So it's a very simple, efficient technology. The preconceived notion is that these analyzers are very expensive and they're expensive to maintain. And maybe that was the case 15 years ago, and that certainly has evolved. Whereas in Waltron's case, you can easily justify just over a couple of years of not having to change your membranes, not having to worry about your sensor. You can cost justify getting something with better technology. But the reality is you want something that's number one, reliable, and you want something that is also going to be maintenance free. You're not going to worry about it. And really that is what the Waltron product is. When you get this oxygen analyzer in the field, our customers will truly forget about it for 5 years. We're supposed to do a calibration every couple of years, but typically, even if you don't do that, it's fairly accurate.
Just, can you explain to me, what is it about the luminescent technology that's making it better for these plants that are cycling up and down more, and then also why you just don't need to worry about them as much as you do with this other technology?
Yeah, when you're saying it right there, number one, you just don't have to worry about doing any kind of maintenance, period. That's a statement. You don't touch it.
Why? I'm not the technical type here. I'm a layman. Probably the viewers understand this better than I do, but since we're chatting, make it clear to me.
Well, everybody's probably familiar with LED lights versus an incandescent bulb. And that's really the best way to look at this is the LED or the light source that we're using in the dissolved oxygen sensor. It pulses, and it pulses at a frequency that we set, but it also pulses based on how much oxygen it's seeing change. And so if it's not seeing a big change, it pulses a little bit longer, meaning that the bulb is going to last even longer. Okay. And so this spot really has at least a 2-year life on it. All right. You don't touch it. You don't do anything about really to the analyzer when the analyzer is cycling. And again, the problem is if you have this other amperometric or galvanic older technology, it's seeing oxygen and then it's going away. It's seeing oxygen, and most of those sensors will last maybe 2 months if you're not going out there and rechanging and remembering and basically changing the battery. And that's really what we're seeing in the field now that these plants are cycling more. And there is one other factor as far as an application that a lot of our listeners will be able to relate to is that the treatments have also changed in the plants, the chemical treatments. A lot of plants now are actually oxygenating their systems. They're trying to raise the oxygen up to create basically a rust layer to protect their system. So now instead of them wanting their DO to be less than 5, they're actually wanting it to be anywhere from 50 to 150 ppb. So now they're constantly at a high level. And in those applications, again, the galvanic sensors are just going to go bad faster. Okay. So not only is it a reliability function, it's an accuracy function, and there is also a response time function. So if a plant comes back online, typically they want good, accurate dissolved oxygen readings immediately. Okay. With a luminescent technology like Waltron has, that technology forces it basically within a minute, this thing is going to be reading pretty accurate. Okay. Minutes later, after coming online, I got a reading. Okay. Whereas in the older technology, again, the response time is going to take at least 10, 20 minutes before it gets to where it needs to be. Response time, reliability, accuracy. For me, it's a no-brainer. And so we are very successful. We're the leaders in the LDO technology in the market. And this is one of the biggest reasons why. Now, when power plants get a brand new panel and they have all this instrumentation that's already spec'd in, typically the manufacturers of the panels try to really cut corners basically and put on the cheapest dissolved oxygen analyzer that they can find in the market, right? And so, unfortunately, is the problem. As soon as we put one of our analyzers in and show our clients that it's just a lot more reliable, it's a lot more robust, and it's just a no-brainer. That's really what I want.
Do you have any examples from a recent client? You don't have to name names of someone that was maybe having issues with their GRA, the old one, and then how we came in and maybe solved their problems and what they've seen, what the feedback is.
Sure. Yeah. Actually, I was out in Pennsylvania and we were in a plant, and we went into a plant that they thought had a pretty good handle on their water chemistry. And they thought that they had a pretty good handle on their instrumentation and calibration. And like most plants, they did for the most part. When it came to the dissolved oxygen, it was that simple test that I was just sharing with you, that me coming out there, pulling the sensor out in the air, and it read 15, when it should have been reading 8,500. So obviously it was low and they had a problem. And so when it was when it was running in operation, it was reading 0.5. So the plant thought, wow, I have no oxygen. Everything's, so once I remembrane, re-electrolyte, so I took care of the probe, remembraned it, and actually got the battery working again, put it back in, let it rinse down, and then it read around 5. Okay, so from 5. And there is a pretty big difference. Now, again, it's that alarming for the plant, but say they did have a little bit of oxygen excursion or something like that, it could have been reading 10 or 15, and they could have been running like that for months, not relying on the instrumentation. So again, one of the things that Waltron does offer is we do these services where we can come in and we'll do a panel assessment is what we call it. And we'll basically come in, and this is for every manufacturer. It's not just Waltron products. It's every manufacturer. We come in and we'll do something like this where we just basically test everything and give them a report and say, here's our honest recommendation. We're not going to be biased. We're going to say your oxygen analyzers need to be replaced, or you need a new sensor, or you need this, or just completely change the analyzer out, or everything's fine. We just need to do a little bit of maintenance. And so we can do some follow-up services. So that's another thing that we do offer.
Excellent. So your piece of advice, though, anybody who feels like getting good readings with the older technology, do an air test. Make sure what you're seeing is real.
Yeah, and that's the other thing is these plants, they have a lot of things on their plates. The operators are in charge of everything from the simple panel to cooling tower pump or something else. And so they have thousands of things on their plate to be paying attention to. And if it's not broke, don't fix it is kind of sometimes the motto that goes around. And so they might forget about something because they have other things that are top priority. Okay. But as you all know, that sometimes these little tiny things, like not knowing that they have a tube leak, or knowing that they have some sort of a boiler extrusion or something going on, it could be catastrophic for the plant long term. So again, we do like to come in and
give us a call in those cases. You're too busy, tap into Waltron. We'll come out, we'll give it a look for you. Look at as much of your plant as you want. We're here for the service too.
And sometimes we can even do some simple checks on the phone. So you can always call Waltron and just get some advice. We're here not just for field service, but we are here for just honestly, listen, we are familiar with every manufacturer out there. It's happened. So Waltron.net, so www.waltron.net, and you can see on there, we have service, we have training, we have all of our instrumentation, including this LDO technology. Check it out.
Yeah, the only thing I was asking, you actually don't even have to do the www, just Waltron.net. It's going to get you there. Hey, Greg, thanks so much for your time. This was really interesting to me. And I think clients out there and people running power plants are going to find this really interesting. Thank you for sharing your insights with us today.
Absolutely. Look forward to seeing you guys out in the field.